This is 4-1 practice for your quiz to review. So we're going to start out by graphing quadratic functions. So you have to make sure you find the y-intercept, equation of the axis of symmetry, the x-coordinate of the vertex, and really all of the vertex. And make a table of values that includes the vertex and use the information to graph the function. So for the first one, we have x squared minus 8x plus 15. I'm going to jump to the other page to do my work. So the first thing we're going to do is find the x value of the vertex. So we know that the formula is x equals negative b over 2a, and in this equation, a is equal to 1, b is equal to negative 8, and when we plug that in, negative of a negative 8 over 2 times 1, so that gives us positive 8 over 2, which is 4. So the x value of the vertex is 4. Now to find the y value, we plug in this x value back into the original equation because we're looking for the y that goes with that x. So f of 4 equals 4 squared minus 8 times 4 plus 15. This is easy enough, you can do it by hand. 16 minus 32 plus 15. 16 minus 32 is negative 16 plus 15 is negative 1. So f of 4 equals negative 1, which tells us that our vertex is 4, negative 1. On the test, I'll just have you state the vertex, but you got to show your work on how you found it. So that's the vertex. Another thing that this formula tells us is the axis of symmetry. We know it's the same as the x value of the vertex, but it's an equation, so you have to make sure you state it as an equation. So the axis of symmetry is a vertical line, that's x equals 4. So that's the axis of symmetry. The last thing we needed to find for part A was the y-intercept. Remember that the y-intercept is when x equals 0. So if you plug in 0 for x, this piece goes away and this piece goes away, and you're left with 15. So the y-intercept is 15, and it will always be that c value. The y-intercept is 15. If you can't fit it on your graph, that's fine. Still state it if it asks for it. I'm going to go back to the other page and plot this. So our vertex was 4, negative 1. 1, 2, 3, 4, negative 1. So that goes right here. Axis of symmetry is a vertical line through that vertex. And our y-intercept we can't fit, so that's all we have plotted so far. Now, since our vertex is at an x value of 4, then this is the center of our graph. So we want to plug in 3 x values above, and below. So we're going to plug in 1, 2, 3, and then 5, 6, 7. And notice because 5 and 3 are the same distance from the x value of the vertex, these two will be twin points, these two will be twin points, and then 1 and 7 will be twin points. So we really only have to find 3 because the others will be twin points. So we can just find those on this page. I'll just make a table. So we've got our x and our y, and in the middle goes our 4, negative 1. So we're going to plug in 3, 2, 1 because that's easier, and we know that will be the same for their twin points 5, 6, and 7. So we'll come over here to do our table. So let's plug in 3 first. So 3 squared minus 8 times 3 plus 15. So that's 9 minus 24 plus 15. 9 minus 24 is negative 15 plus 15 is 0. So f of 3 equals 0. So that tells us the point 3, 0 is on the graph. So in my table, I'm going to put 3, 0 and then 5, 0. Because I know they're twin points, so they have the same output. Now we'll do 2, so f of 2. Remember, always use parentheses, especially if you're using a calculator. Don't want you to mess up the negative. So 2 squared is 4, minus 8 times 2, which is 16, plus 15. 4 minus 16 is negative 12, and negative 12 plus 15 is 3. So f of 2 is 3. So we have 2, 3, and then 6, 3, and then we have one more left. Let's just do this one in our heads here. Plug in 1 here, so this 1 squared would be 1, minus 8 times 1, so 1 minus 8 is negative 7. Negative 7 plus 15 is 8. So we get 8 for that one, and 8 for this one. And so now we're just going to plot those points. So 1, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then it's twin point, so I can go like this, 3 away, same height. And then we have 2, 3. So that's going to be over 2 up 3. Same thing. 2 away, 2 away. And the last point is 3, 0. That's just right here, and then its twin point will be there. So we have our nice quadratic, and then you're going to draw a line that connects it with arrows. You got to have arrows to show it goes on forever, and that's graphing the quadratic. Now we'll go on to number 2. Okay, for number 2, we can see that this graph's going to open down because of the negative x squared. The a is negative, so this will have a maximum. That first one had a minimum. And we're going to do the same thing here. First, we're going to find the vertex. So b is equal to negative 4, a is equal to negative 1. Plug it in. X is equal to negative of a negative 4 over 2 times negative 1. So that's positive 4 over negative 2, which is negative 2. So that is the axis of symmetry and the x value of the vertex. So axis of symmetry, x equals negative 2. And then to find the y value of the vertex, we have to plug that in to the equation. So f of negative 2, this is where you really need to be careful with the negatives. You have to put your input in parentheses. It's negative of a negative 2 squared minus 4 times negative 2 plus 12. What people make the biggest mistake on is they don't use the parentheses and then they say negative, negative. Negative, negative is a positive, but that's not true. You have to square first. So when we do square the negative 2 first, we get a positive 4, but we still have the negative on the outside, so it's a negative 4. So no matter what, when you have a negative x squared, the output for this little piece will always be negative because of the negative on the outside, regardless if your input is positive or negative. So you have to be careful. Otherwise, you're going to get a really screwed up answer. So then we get negative 4, and then negative 4 times negative 2 is adding 8 plus 12. Negative 4 plus 8 is 4, plus 12 is 16. So f of negative 2 equals 16. So that tells us our vertex is at negative 2, 16. And then the y-intercept is just the c value, or when you plug in 0 for x, so it's just 12. Now for this one, since our vertex is so big, we need to change our scale to go by 2's, which is perfectly fine. So back to our graph. If you're going to do this, you got to tell me. So we're just going to label our points here so we know what's going on. And then so this would be negative 2, and we'll make this go by 2's as well. Okay, now let's plot the vertex, negative 2, 16. So that's going to be ignore those 2 lines right there. It won't let me erase it. So negative 2, 16 will be right here, and we're not going to be able to fit a ton of spots. Oh wait, this is opening down, just kidding. And then we can fit our y-intercept of 12. And then our axis of symmetry is here. And then we already have a twin point. Since we know the y-intercept, we have a twin point right here. So that's actually 2 away from the axis of symmetry because we're going by 2's. So you have a choice. You can do 1 around the vertex. So like when we make our table, we know the center is at negative 2, 16. You can do negative 1, 0, and 1, and then negative 3, negative 4, negative 5, or you can go by 2's so that you won't be in the middle here. I'm going to just go by 1's because they'll be easier to plug in. And then negative 3, negative 4, negative 5. So we actually already have 0, which is 12. So 0's twin point is negative 4. So negative 4 also has the output of 12. Now we just have to plug in 1, negative 1, and whatever 1 is twin point with negative 5, so they'll be the same output. Negative 1 and negative 3 will have the same outputs. So first let's find 1. F of 1 is equal to negative of 1 squared minus 4 times 1 plus 12. So 1 squared is 1, so it's a negative 1 minus 4 plus 12. So that's negative 5 plus 12, which is 7. And we'll just go ahead and do the other one here. So f of negative 1, which will be our other point, is negative of a negative 1 squared minus 4 times negative 1 plus 12. So a negative 1 squared is positive 1, but the negative on the outside makes it negative again. Then negative 4 times negative 1 is positive 4 plus 12, so that's going to be 16 minus 1, so that's 15. So f of negative 1 is equal to 15. So negative 1 is 15, 1 is 7. 15 and 7. And now we can plot those. So we have negative 1, 15. So that's going to be in the middle right here. I'm going to fix that. So it'll be right here. And then the twin point will have negative 3, 15. Then we have 1, 7 and negative 5, 7. So 1, 7 will be right here. And then negative 5, 7 will be right here. And then again we can draw the rest of our quadratic here, going through the points. And there's our nice quadratic with arrows. And remember, we expected it to open down because of the negative in front of the x squared. One more to graph here. 2x squared minus 2x plus 1. First thing, find the vertex, negative b over 2a. b is negative 2. a is 2. So x equals negative of a negative 2 over 2 times 2. So that's positive 2 over 4, which reduces to 1/2. So 1/2, that's our axis of symmetry. X equals 1/2. Now let's find the x value of the vertex by plugging in, the y value of the vertex by plugging in the x value of the vertex. So 2 times 1/2 squared minus 2 times 1/2 plus 1. This will be nice. 2, 1/2 squared, okay, maybe it's not. 1/2 squared is 1/4 minus 2 times 1/2 is 1 plus 1. So this is going to zero out, and we're left with 2 times 1/4, which is 2/4, which is 1/2. So our y value of the vertex is the same as the x value of the vertex. So our vertex is at 1/2, 1/2. Now our vertex is not nice, so twin points can be difficult if this happens, but because it's a half, it won't be. To find twin points, 1/2, 1 and 2 are the same distance from 1/2, so we'll be fine. We get to do a whole number input. So we can do also 0 and 3, because 0 is 1/2 from 1/2, and 3 is also 1/2 from 1/2. If it was something like 2/3, that's when we have to be careful, because if you wanted to use whole numbers, you'd have to use 1, which is a third away, and then you also need to use, and that needs to go over here, actually it's greater than. So 1 and 2/3, 1 is 1/3 away from 2/3, so 1/3 the other direction would be 1/3. So that means 1/3 and 1 are twin points. So you would always have a fraction for a twin point. Otherwise, if you just plug in whole numbers, you won't get twin points, which is fine, but you just got to know that you won't get twin points. Okay, so let's find the y-intercept, and again, that is just the c value in standard form, so that's 1. And if you plug in 0 for x, that will give it to you too. Let's go back and graph all these. Okay, so we're graphing these. 1/2, 1/2. So we're going over 1/2, up 1/2, so we'll be right in the middle here. And then we know the y-intercept is 1. So that tells us the twin point here is 1, 1. So we had 0, 1, and then 1, 1. Because 0 and 1 are both a half away from the axis of symmetry, which is 1/2. So then let's make our table here. And we get in the middle is 1/2, and then we have 1, 0, -1, -2, and their twin points will be 2 and 3. So I already know that 1/2 has 1/2 as the output, and then I also know that 0 has an output of 1 and 1 has an output of 1. Now let's find -1. It's up to you if you think that doing negative smaller values are better or positive. I'm going to go ahead and do 2 and 3. So we're finding 2 first. 2 times 2 squared minus 2 times 2 plus 1. Remember to square first, so it's 2 times 4, 2 squared, minus 2 times 2 is 4 plus 1, so that's 8, and then this would be -3, so the output's 5. F of 2 is 5. So we got 2, 5, and then its twin point will also have an output of 5. Go ahead and find 3 here, so it'll be 2, not 3. 2 times 3 squared minus 2 times 3 plus 1. Square first, 2 times 9 minus 6 plus 1 equals 18. That's ugly. Okay, 18. These two together is -5, and 18 minus 5 is 13. So f of 3 is equal to 13. So we'll put those two on our graph. So it's 2, 5, and that'll be -1, 5, and 3, 13, and -2, 13. So let's finish graphing these. So 2, 5, -1, 5. 1, 2, 3, 4, 5. And then -1, 5. And I don't think we can fit 13. Nope. So we can just leave it at those points. Like this. And I forgot to draw my axis of symmetry, so I'll do that now. It's at 1/2. So just do your best to be in the middle there. And then that's it for graphing. So we've got those 3 done for graphing. The next part of this worksheet is finding out if it's a max or min, finding that value, then stating domain and range. First, it asks you what the maximum and minimum always occurs at the vertex. So that's what we're trying to find in these problems, is the vertex. And we're talking about the y value, not the x value. The max or min is only the y value, because we're talking about heights, which are outputs, which is the y value. So x squared plus 2x minus 8, first of all, let's determine if it's a max or min. Because the a is positive here, positive 1x squared, this will be a minimum because it opens up. So all we have to do is find the vertex. So again, -b over 2a. b is 2 and a is 1, so we get -2 over 2 times 1, so that's -2 over 2, which is -1. So that's the x value of the vertex. Find the y value of the vertex, so f of -1 in parentheses, -1 squared plus 2 times -1 plus, nope, just kidding, minus 8. And then -1 squared is +1, plus a -2 minus 8, -10 plus those two together, -10 plus 1 is -9. So that means our vertex is at -1, -9. We know that this has a minimum, and that is the y value of the vertex. So the minimum is -9. That's the smallest y value. So back over here for our final answer, we're going to say that the minimum is -9, and that means that our, let's do domain first. Domain for all of these, what can you put in? What can I square, then times by 2, and add those together and subtract 8 from? That's always any number. So domain will always be all real numbers. And then my range, since this is a minimum, this is the smallest value y will ever be. So y can only be greater than or equal to that -9. Okay, on to the next one. We got to determine if it's a min or max. So since the a value is positive again, this will be a minimum because it will open up. Again, finding vertex, x equals negative b over 2a, b equals negative 6, a equals 1. So x equals negative of negative 6 over 2 times 1. So that's positive 6 over 2, which is 3. That's the x value of the vertex. To find the y value, plug it back in. So x equals 3 squared minus 6 times 3 plus 14. 3 squared is 9 minus 18 plus 14. These together are negative 4. So it's 9 minus 4, which is positive 5. So f of 3 equals 5. So that tells me that my vertex is 3, 5. And we know it's a minimum, and that's always the y value. Min or max is always the y value, so 5 is our minimum. So 5 is our minimum. So we said the minimum was 5, and again, our domain is always all real numbers, and our range, since that's a minimum, y is greater than or equal to 5. Number 6, we have a negative a value this time, so that means it's a maximum because that negative a value makes it open down. So again, finding vertex, x equals negative b over 2a, b is equal to 14, a is equal to negative 1. So we have x is equal to negative 14 over 2 times negative 1. So that's negative 14 over negative 2, which is 7. That's the x value of the vertex. To find the y value of the vertex, plug in 7, the x value, to the quadratic. So negative of 7 squared, got to use parentheses, plus 14 times 7 minus 57. So it's negative of 7 squared, which is 49, so that's negative 49 plus 14 times 7, which is 98, minus 57. 98 minus 57 is 41, positive, so it's negative 49 plus 41, which is a negative 8. So f of 7 is negative 8. So that tells me that my vertex is 7, negative 8. So my minimum, again, is the y value. Well, this is a maximum this time. So my max is negative 8. That's the maximum y value my quadratic has. So my maximum is negative 8. And then my domain, all real numbers. And my range, since that's a maximum this time, that's the highest it will ever be. So y can only be lower or equal to negative 8. So less than or equal to negative 8. One more in this one. This again has a negative a value, so we're going to have another maximum here because that makes it open up. So we're finding the vertex. B is equal to 5, a is equal to negative 1. So x is equal to negative 5 over 2 times negative 1. So that's negative 5 over negative 2, which is positive 5 halves, or 2 1/2. I suggest when you have fractions that you always leave them as fractions and not decimals. Makes it easier when you get here. Because if my final answer is a nasty decimal, I want the fraction. So doing it this way will guarantee you get that fraction without having to mess with anything else. So find the y value, f of 5 halves, so f of negative, and then 5 halves in parentheses, squared, plus 5 times 5 halves, minus 1. 5 halves squared, you square the top, square the bottom, so it's 25 fourths, but it's negative because the negative is on the outside, plus, multiply fractions across, 25 halves minus 1. Get a common denominator of 4, so negative 25 fourths is already like that, and then this would be 50 fourths, just times each by 2, and then minus 4 over 4, so that's just 1. And then negative 25 plus 50 is positive 25 fourths, minus 4 more fourths would be 21 fourths. And then your final answer for your y value, you can change that. Since we don't have to plug it into an equation or anything. And in your final answer, you can go ahead and state this as a non-fraction. The only time I don't want you to, in your final answer, to state it as a non-fraction is if it's a repeating decimal. And so, like, if this ended up being like thirds, but this is like 22, then you would say 7 and a third. So you can make it a mixed number. So that means that our vertex is, I'm going to do 5 halves and then 5 and a fourth. And so that means, again, this was a maximum, so our maximum is 5 and a fourth, or 5.25. Then our maximum, again, is 5 and a fourth. And our domain, as always, is x's, all real numbers. And then the range, again, this is a maximum, so, oops, I drew this picture wrong, ignore that, up, opens down. So our range, since that's a maximum, that's the highest it'll ever be, so y is less than or equal to 5 and a fourth. And that's all for the minimum and maximum. Now for the story problem. They charged $20 to participate, and then 70 people attended the classes. They want to increase the class price this year, but they expect to lose one customer for every $1 increase. So if you remember, we did a couple of these in this section for homework. We did one in class, and so we have to define some variables to figure this out. So what price should the club charge to maximize the income? Well, we need to create an equation that helps us find the income. So I know that income, I want income to be my y, so my income is going to be price per class times number of customers. Price per class, number of customers. And all of this depends on what I charge and how many times I increase my price. So we're going to say let x equal number of increases. And so if x is number of increases, we're going to say let y equal income. So we're going to say y is equal to, now our price per class. Right now it's $20. If I'm going to increase it by $1 increments, I'm going to add to that $1 per increase. So if so this tells me that the number of increases times that by $1 and add that to the price, and that'll be the total price of the class. So like if I increase it 5 times, that'll be a $5 increase, so $25 per class. And I'm going to multiply that by my number of customers. I expect to lose one customer per $1 increase. So right now I had 70 people take the class. So that's going to decrease, so take away 1 per increase, so that's why you multiply. So if I increase it 5 times, I'm going to lose 5 customers, which would give me 65 total customers. So then just following with that example, then I would have, if it was a $5 increase, it would be $25 for 65 customers. And then multiplying that out would give me the total profit that I make for 5 increases, which would be $1,625. Now that's just an example. I just wanted to show you what it meant. So I'm just going to block that out. That was just to show an example. Okay, so now we're going to, since this equation relates profit to number of increases, we're going to find the maximum profit. So we're trying to find the maximum of this quadratic, because y is our income. So since max and min are always our y values, the maximum of this function will be the maximum profit. So we can use a calculator here, but what we want to do is multiply that out. So we're going to FOIL. So we got 20 times 70, which is 1,400, minus 20 times negative 1x, so that's negative 20x. And then we have 1x times 70, so that's plus 70x. And then our last part, 1x times negative 1x, is negative x squared. Let's combine like terms and write it in standard form. So the x squared comes first, negative x squared. Then these two are like terms, so that gives us positive 50x, and then plus 1,400. Now we want to find the vertex. So again, x equals negative b over 2a. And what the x value is number of increases. So that's going to tell us the number of increases that will make us the most money. And in this case, a is negative 1 and b is 50. So we'll have 50, negative 50, over 2 times negative 1. So that's negative 50 over negative 2, which is positive 25. Now that seems like a really big number, but it's going to end up working out. This is why guessing and checking isn't always the best method, because if you were trying to guess and check, you'd have to do this more than 25 times to figure out that that was the maximum. So that's annoying. So x equals 25. So you're going to have to increase the price 25 times in order to make the most money. Well, how much money will you make? So we're going to plug in 25 into this equation to figure out how much money I make. Or you can actually plug it in up here if you'd like. That's actually easier because it will tell you the price per class and how many people you have right away. So let's go ahead and do that. It's easier and it tells us all the pieces of information we want to know. So, and it's equal to this. It's the same thing as this function. It's just multiplied out. And we needed to multiply it out to get the B and A. Otherwise, you couldn't find A and B. So I'm going to go back to the nice one and plug in 25. So y is equal to 20 plus 1 times 25, which is obviously just 25. And then 70 minus 1 times 25, again, just 25. So that's 20 plus 25, 70 minus 25. Do what's in parentheses first since we can. No need to FOIL. So that's $45 for 45 customers. And then when you do 45 times 45, you get $2,025. So that's the max amount of money you make, is $2,025, and that's for 45 customers charging $45 a piece. So back to our questions, it says, how much did the club charge in order to maximize the profit? So we saw that that was $45. And what is the maximum income they expect to make? And that's $2,025. So they didn't really care about the number of people, but they did, for the question, at least ask the price per class, which we needed to remember that price per class was our X value, 25, plus 20, what they had originally, because they increased it by $1 25 times. So make sure you know how to interpret your answer. And that is it for this first worksheet. So I hope that really helped you, and I will go on to making the next one.